Okay, picking up where we left off on page 187, we're talking about this top-level contextual data flow diagram, a DFD. And so this contextual model is just the top level, and like I said, normally the entire process that you're working on fits on this one page. The next step is to draw what they call a level 0 diagram, which is the top level, with the least amount of detail. So it really should maintain the same data flows. In other words, these entities ought to remain the same. And so even though you zoom in, you're probably going to create data stores which don't show at all here. You're going to show lots of other processes which don't show here, and lots of arrows pointing around which don't show here. But when all's said and done, the student record system, and the instructor are all going to be the same. There shouldn't be any additional arrows. And in fact, if there are additional arrows, that probably means you missed something and you should probably go back to your contextual diagram and fix it. Okay, so same data flows in both directions. It's an exploded view of this first one. And when you create a level 0 guy, you end up with a parent-child relationship where, the upper level one becomes the parent, and then you have a child relationship that gets progressively more fine-tuned. And the point is, you're supposed to continue doing a level 0, level 1, level 2, level 3 until you get to the point where you couldn't logically go any further. Now, this is somewhat subjective, and they call it functional primitive. When you get to the functional primitive, you should stop. And where you should stop, that's kind of, sort of, again, subjective. If you kind of know your people you're dealing with, you can kind of tell whether or not they're going to be able to handle an awful lot of detail or not. And I'm saying it's more audience, what's the right word, dependent. If you have a very high-tech audience who loves detail, then you might go down to level 3 or 4. If your audience that you're showing this to isn't all that great, then maybe a 1 or a 2 might be where you're going to go. Now, remember this whole discussion that one of the reasons you're going through these diagrams is to teach you, the systems analyst, how everything puts together. But quite frankly, after you've been on the job, for 5 years, you probably know all this stuff, right? Well, the other part of this is to teach the client, the user, what's going on. And teach is probably a bad choice of words, but this is basically a method of communicating to the client. So just because it may, after several years of doing this may provide you no benefit whatsoever. Zip, zero, none. You look at the diagram, you can just do one in your sleep. Brrr, done. That's not all what it's about. It's about trying to explain these things to the customer, because the customer's going to look at this and go, but wait, what about this? And you go, oh. So that's what it's supposed to facilitate this communication. That's what it's all about. It's not just the idea that, well, the purpose of this is to generate a diagram. A diagram? We're paying you money to generate diagrams? I certainly hope not. You're supposed to be helping us design this new system. So again, the point of the story ain't to do them both. So on the bottom of page 190, they show both the contextual diagram and the level 0 diagram together. And you can kind of see the difference, and you can see how it goes into more detail, where there's 1 data store and 3 processes, but the student record system and all the rest of those kind of things remain essentially the same. Okay. The next step after that is, continuing on page 192, is to draw these lower level diagrams. And as you draw these things, there's 2 rules that you should use. One of them is called leveling. Leveling is the one where you just continue to grow more detail until you get to those functional units that really can't logically be subdivided any further. Now, I'm not saying that they can't be. It's just that you would get into so much detail that unless it's required, I probably wouldn't recommend it. The other one is called balancing. And that is, as you draw these diagrams in more and more detail, you got to make sure that your arrows are all in the right direction and you have the right number of arrows and they're all pointing to the same thing. So in other words, even though you zoom in and zoom in and zoom in, you know, the student still has graded work and submitted work coming in and out of the system. That doesn't change. So that's what they call by balancing. Okay. In fact, on page 195, they kind of show an example of a zoomed-in version where they zoom into one tiny little process and then, you know, put a magnifying glass on it, and doing, up pops another one. But you can tell that all the pieces are still there. The entities are still there. The other processes are still there. All they did was just kind of zoom in. And so that's the balancing thing. Actually, there's a better example on the next page, on 196, where they actually show you know, a contextual diagram and a level 0 diagram, and you know, they don't move things around. I mean, the entities are still in the same corners, and it's fairly obvious that all they did was just take that little center square and zoom into it to get more detail. Okay, so that's data flow diagrams. So a test question might be, you know, who are the customers of a data flow? You know, which people are data flow diagrams designed to help? You better have an answer for that. Okay, starting on page 197, they talk about the data dictionary. If you're a database kind of person, you might think that we're talking about a word called schema. Schema is a way to describe a database. It's not necessarily the data in the database. That's not what we're talking about. We're talking about describing the database itself. And in the book, they kind of go into a little bit more detail than you normally would in this phase of the analysis, but I'll grant the author that it could be done. So a data dictionary or a data repository is a central storehouse of information about the system's data. And let me tell you a story. There are some people who actually have the title being the data dictionary holder, the data repository holders. And the reason is, let's say you got a big company that's got a gazillion different things. And wouldn't it be cool if in every single database for vendors and customers and clients and everything, that when it came to the name, they were all called last name, first name, you know, middle initial? I mean, when you're creating a database, wouldn't it be kind of cool to look up a data dictionary and see how everyone else used last name? Because you don't want to do L name and F name if everywhere else in the entire database they use the words last name, first name. So this data dictionary is very helpful at finding out how other people have set their database up. But back to the particular context of this chapter. So this analyst uses the data dictionary to collect and document the data requirements, and you could get all the way down to the fields in the database. So, and you should be able to talk about the relationships in big terms of how one particular piece of data over here might relate to another. Okay, so if we get that far, then we have to talk about the parts of this database. A data element in the book. If you're a database person, this would probably be a field or a cell. If you're in a cell, you're a spreadsheet kind of person. But a data element is just one thing, like last name. That's it. That's what a data element is. And they're combined into records. So, or a row if you're a spreadsheet kind of guy, a record if you're a database guy, or a data structure if you're one of those crazy people who do tuple algebra for a living. Okay, and a record is a meaningful combination of related elements. So typically, the record is the kind of the low-level, complete thing. It's going to have the record is probably what's going to be passed around, for example, in these data flows, or it could be multiple records. But the point is, you would rarely pass around a piece of a record. You probably, from this perspective, you're passing records around. Okay, so data dictionary. And on page 198, they talk about using tools to help develop these data dictionaries. And yes, there are some case tools that you can go through, and it's just like a fill-in-the-blank form where you go through and you give it all the things you know. The point of this is to document every single element, and using one of their examples. Let me just skip to the example because it makes a heck of a lot more sense. So for this particular example, this is using their case tool to come up with a field in a database. Now, it doesn't even matter what table we're talking about. That's not relevant at this point. But this is Social Security number. So they have the full title and then an alias. Now, okay, that kind of makes sense. So now, because occasionally you'll be in a database someplace and it'll be, FN, and you're going, what the heck does that mean? Wouldn't it be cool if you had a data dictionary? You could find out what that abbreviation meant in your database? Okay. The type of the data and the length of the field. For this particular case, the type is numeric, and it goes to 9 digits. So Social Security number is 9 digits. It has no default value, although perhaps a default value of 0 would have been appropriate. The source, where is this coming from? It's coming from some form. And what are the acceptable values? Basically, it will take any positive integer that's no more than 9 characters. Now, this is the point where you could have some really cool stuff. You could say, a range of numbers. For example, you're typing in the age. A real, honest-to-God value, acceptable values for age probably is going to be like from 0 to 120. So if somebody put in a -4, it'd be no good. If somebody actually, they're typing 15, but they actually typed 150, it would flag it and go, nah, you're not 150 years old. So those are called domain rules, where you give it an upper and lower bound, or perhaps you give it, a better example of a domain rule is, you can only answer, what's your favorite color, but you can only choose between, red, blue, yellow, and green. And so those are the only 4 that it'll accept, and so you can't put in purple. So here you're documenting what the acceptable values are for each one of these things. And of course, the more information you put in here, the less likely that when you hand this off to your database person, they're not going to be calling you on the phone going, what did you want? I'm kind of confused. The whole point of this is when you're done with this point, you can have your programmers go run off and do programming things, and have your database people run off and do the database things, and they won't be pestering you. Okay. So, let's just kind of go through, we kind of did this. So it's the data element name, the label, the alias, the type and the length, the default value, acceptable values, either a domain or some sort of validity rules like a upper and lower bounds, the source, security, responsibility, which is a good one. Who's responsible for, who owns this data? If something is wrong, who do I go to? If it gets corrupted, who do I go to? That's a good one to have. Okay. The next in the data dictionary is they talk about, on page 200, they talk about the data flow. So the data dictionary is not necessarily all about data. It's also, here is a piece of data, and here's where it's going to go. And all it basically is a listing of the sources and endpoints for this data. And this one piece of data may travel lots of places. It may go in this one particular process, it may go around over here. Then you have another process over here, and it goes around over here. So you might have multiple one of these guys. So you're basically just listing where all this data is going to go. So it's kind of cool. So to make sense of this, your data flows have to have a name, and typically the names are the associated processes or entities. Like it's the from to kind of a naming convention. And it basically, the origin and destination are the key part of this thing. And it would be kind of cool if in here you would kind of estimate, based upon just gut, how much traffic is going to happen, how much data. Because once again, when you hand this to the database guy, they'll know how to tune the database for either being low activity or high activity. Okay, once again, we're coming up on the 15-minute mark. And we'll pick this up again in just a few.